Hello, this is Robert Van Cleave with my audition movie on the topic of NoSQL Data Modeling. As you can see in the course, today's lesson will be transforming the logical model into a document model. Go through the lesson overview quickly. The goal is to translate a portion of the logical data model into a document store to support a Customer 360 view. We'll go through the steps that are involved. We'll do a Customer 360 mind map. We'll look at the JSON tree and document for that same structure, and then we'll review the lesson. The first step is to identify the relevant entities from the logical data model. Next, we determine the root entity. Then we make some structural trade-offs. We determine which objects need to be arrays versus just nodes. We determine where the nodes placement are, specifically for the payment entity. And then we take into account some denormalization. In our case, it will be product and product category. So you'll recall the logical data model with all the entities that we know about. We're going to remove the account and account entry because they're not really interesting for this view. And we're also going to denormalize product and category and move them into the line item. Now let's see what that looks like with the Customer 360 mind map. In the interest of time, I've drawn the map ahead of time, but we could go through that each step in a separate lesson. You see here that we have the customer data, the ID, name. We have the email, address, and phone. For those last three, the contact methods, I've made the decision that we'll only have one. While the logical model lets us have multiple, in this particular application, we only care about the most recent. It simplifies the structure a bit and makes it a little bit easier to deal with. Now we have to consider the order, item, and payment entities. So when we look at the orders, we move them in. You can see the order number, order date, ship date, total amount from the order entity. We also have an additional array within the orders for line items. That would have line item, line number. You see here also we've included the product ID, the product name, and product category, which used to belong in the product entity. The line item also has a quantity, the item amount, as well as the total for the line. And in this first iteration, we see that the payments are associated directly with the orders. We have a choice here. If the payment is made when the order is placed, then this makes perfect sense and we can always see what payment was related with the order. But in this particular scenario, we're going to move the payments out at the same level as customer. That lets us see all the payments that were received at the same time. You'll notice that I've named the arrays in plural, so we have orders, payments, line items, instead of singular like we did for the email, the address, and the phone. Now we'll look at the tree view of the JSON document, and we did this just in a JSON editor. So you see the customer entity with the information related to that. We have the order entity down below. We have the line items within the order, and then we have the payments back under the customer. Likewise, for the JSON document itself, I apologize for it being a little bit small. We have the customer, we have the orders, we have the line items. You'll notice there are two line items here. If you recall, the JSON document is actually an instance and not a schema. And finally, we have the payments, where we've also shown that there are two. We haven't typed in the values because that's not useful for this discussion. So in the way of a review, we've selected the relevant entities from the logical model. We've created this tree structure or hierarchy by determining the root node, establishing the cardinality, and determining the nesting level for each of the entities. We denormalized where it was needed, and then we documented our results, first as a mind map and then as a JSON document.